Good afternoon, everyone. Thank you for sticking with us during the lunch hour to hear the very last presentation of the day titled UIC NPDES Regulatory Framework Considerations and Inspection Requirements. I'm Amanda Mars with the Department of Ecology and will be your moderator for this session. There should be time for a brief Q&A following the presentation. You have the opportunity to submit questions to today's presenters by typing them into the chat box. I would now like to introduce our two presenters, Doug Howie, Senior Stormwater Engineer with the Department of Ecology, and Martin Nelson, the Utility Engineer for the City of Kennewick. I think that's Doug's cue to take it away.
You're muted, Doug.
I got disconnected, so I didn't know exactly what was happening. Have I been introduced? Can I start?
Yep, yes.
Okay, thank you. That's going really well so far, you can tell. Thank you very much for being here. I appreciate your being here. Now I got to figure out which thing I got to do so I can move forward. There we go. So why are we talking about underground injection controls at a place where we're talking about the municipal permits? Well, the primary reason is section S2.A.1 of the municipal permits, where the permit just authorizes discharge to groundwaters of the state for most purposes, unless they're being set in to the ground through UIC devices. Those are not authorized under the permit. So we have two different ways of looking at things here. When we're dealing with stormwater, particularly when stormwater is going into the ground, we have the National Pollutant Discharge Elimination System, municipal permits, and we have the Underground Injection Control Program, which is run by a WAC rule, Washington Administrative Code rule. And so when you're putting things into the ground, stormwater into the ground, in the case where you have UICs involved, then there's some choices that the designer and the community have to make as to the kind of treatment that you need to do before putting water into the ground and what you have to do in terms of registration of these devices with the state. Now, these two programs do overlap. The UIC program doesn't have its own set of BMPs. It uses the BMPs that are in the manual, the Eastern Washington Manual and the Western Washington Manual for the UICs, for things like dry wells and infiltration trenches and things like that. So it actually does use those things to meet the ACAR requirement that's in the WAC. And the picture of the WAC here is we created clear back in 2006. They created a guidance manual for the WAC. Now, Ecology made a very conscious decision to separate UICs from the municipal permits. They felt that there were two different ways of dealing with them, and they didn't want to get things overly confused, but things have become confused. And so now we're trying to work things out from that confusion. So here's a small list of things that we identify as being part of the UIC rule and part of the MS4 permit.
We can't see your screen.
Yep.
Your presentation.
Try share.
Can't? Okay, so whatever happened to my, hang on.
We're seeing your video. There you go.
Can you see the screen now?
Nope.
I gotta get into, hang on. When I was doing that crazy thing with, I gotta share my screen again here. Figured out how to do that now. Share my screen. Share the correct one. You see my dog now?
Yes.
You can see your dog?
Hallelujah. There we go.
Perfect.
All right, hallelujah, okay. I am now 6 slides in. Hopefully you didn't miss much. There wasn't much on those slides. So here's a comparison between the things that are in the UIC rule and the MS4 permits. So runoff treatment, we have that in both of them. Operation and maintenance, source control, local ordinances, the construction SWIP in the MS4 permit, and the UIC rule requires that they protect the well during construction and deal with runoff from that site and keep it off of the grounds off site from where you're building that well. UIC rule has a registration process that goes through Ecology. Mary Shalene Hansen is our single UIC expert at Ecology, and so all the registration process goes through her. MS4 permit, there's a stormwater site plan that you have to submit, and the local jurisdiction is responsible to reach that. There is outreach, and then the bottom three are where things start getting a little bit different. Okay, so on the UIC rule, they have to do some certain outreach about UICs and protecting UICs and how that's dropping water deep into the ground. They have to be potentially do some closures of the UICs if they're not protecting groundwater. And there's a well assessment that was required for all wells built before 2006. I don't know that that's been done for all wells built before 2006. And 2006 is picked because that was the year that the WAC was put in place. So they had existing wells are those wells that were built before 2006, and new wells are those that are built after 2006. But in the MS4 permit, there's also on-site stormwater management issues you need to deal with, flow control, meaning dealing with runoff from the half to 2 year and up to the 25 year, whereas in UIC, all the water is going into the ground. And since water is going in the ground, there's not a lot of wetland protection concerns under the UIC, but they do cover very similar issues, and under the similar issues, they deal with them in similar ways. And the UIC rule does borrow from the UIC, from the NPDES permit and the stormwater manuals. And so one of the thoughts behind the process was, if you keep all runoff goes into a UIC on your project site, then you can follow the UIC rule for designing that site for treatment. If you don't have all runoff in that for that project site go into the UIC, then you need to design that UIC as a infiltration BMP, but you have to design the treatment for that under the NPDES permit requirements, the core elements or the minimum requirements, depending upon which side of the state you're on. So what constitutes no discharge to the MS4? In Eastern Washington, Ecology is suggesting that the jurisdictions use the 100-year 3-hour and or the 100-year 72-hour storm, whichever one is larger, to constitute all runoff. There can be a storm larger than this storm, and you can get discharge from the UIC into the MS4, but we don't think you need to design those things under the MS4 rule. You can leave them under the UIC rule at that time. Local jurisdictions are free to use other numbers. If they want to use the 50-year storm, the 25-year storm, that's fine. This is strictly a suggestion. In Western Washington, we don't have a suggestion. In Western Washington, you have to keep the entire runoff file generated under the modified site conditions out of the WWHM has to stay on site. So that means all the runoff from that 60 years of rainfall have to stay on site. So to meet the UIC rule, you have to do two things. You have to register your well, and then you have to show that you are applying all known, available, and reasonable methods of prevention, control, and treatment. You have to show you're meeting ACART. And you need to show Mary Shalene Hansen you're meeting ACART. And if these two requirements are not met, then you can't do things through the rule authorization. You may end up having to use the MS4 designs, core elements or minimum requirements, or you will need to get a state waste discharge permit if you're going to be keeping using that infiltration facility. So what are UICs? Bored, drilled, or driven shaft whose depth is greater than the largest surface dimension, dry wells. Catch basins that are that have no bottom on them, but that are deeper than the 2x2 size of the top. A dug hole can be done that way. An improved sinkhole is that way. Now, this fourth bullet is a bullet unto itself. It doesn't have these dimensional requirements. It's essentially an infiltration trench. And you can have an infiltration trench with a distribution pipe that's perforated, or a infiltration trench that doesn't have the pipes. If it has the pipes, it's a UIC. If it doesn't have the pipes, it's not a UIC. So other examples, drain fields, infiltration trenches with perforated pipe, storm chamber systems, these yellow things on the left-hand side, if they're designed for infiltration, EPA has declared those as being UICs. The criteria here that we're looking at is what direction is water going? Is water coming out of the pipe through the perforations and infiltrating into the ground? It's probably a UIC. If this is a trench or something that is gathering water, putting into a pipe and moving the water from that pipe, using that pipe to move the water away, like an interception trench, then that is not a UIC. So it has to do with the direction of flow into or out of the perforated pipes. Some examples of things that are not UICs, pipe that collects water, as I talked about, big infiltration basins where the surface dimension is greater than the depth, and infiltration trenches without perforated pipe. I mentioned the treatment for UICs is a little bit different. You use a 3 set of matrices, one to identify the treatment capacity of the existing soils, another one to identify the pollutant loading capacity for that site. And then you find where those two intercept, and that's what you end up having to do. If it's insignificant load, 2-stage dry well is going to work for you. If it's high, you're going to have to put in oil removal and basic treatment. A couple of quick questions, comments on the matrix. A catch basin with a downturned elbow is not pre-treatment, so don't talk to us about it being pre-treatment. Pre-treatment requires a BMP approved for pre-treatment. Remove solids means providing basic treatment from that. And infiltration trenches are a unique beast. They are UICs, but you use the criteria in the manuals at all times when you're designing infiltration trenches. You don't use the matrix, the UIC matrix that I just showed you 2 slides before. You have to follow in Eastern Washington, you have to follow BMPC 6.22 for flow control and F5.20 for treatment. And in Western Washington, you have to follow BMP T7.20. Infiltration trenches, the only thing UIC wide you have to do for infiltration trenches is register them. All the rest of the design is done in accordance with the criteria that you would use for core elements or minimum requirements. And I've gone past my time, Martin. I'm sorry. I'm passing the torch. Phew. It's all yours, Martin. If anyone has questions while he's preparing, I am stopping to share.
Okay. Let me get my share screen going here.
There you go. I stopped sharing.
Well, it doesn't want to share. Hold on. Here we go. Wait for it. All right, you guys have a full presentation in front of you?
We're seeing the presenter's notes.
Oh, awesome.
Well, so you're going to want to go over to display settings right up to your upper left. You had it correct.
Let me do this, see if we get this right. How's that?
We've done a lot of practice on this, you can tell.
So go to the upper left where it says display settings.
Okay.
Pull that menu down. Right there. Yep. and then swap your view.
How's that? Is that better?
Not yet.
Not yet.
You're seeing the same thing?
It's looks frozen.
Okay. My screen sharing is paused for some reason. Okay, how's that?
I'm seeing your edit mode.
Okay. Let's try this again. So now what are you seeing? Are you seeing a desktop or are you seeing a presentation?
We're seeing you in your
Oh, that's great.
your video camera, your face.
Cool. This was yesterday.
So do we want to open it to questions for Doug for a minute or two while we get that set up? Does anybody want to share some questions in the chat box? Oh, wait, never
There
mind.
you go. We got you.
Okay.
It worked.
Right. All right. So, hi, my name is Martin Nelson. I work for the City of Kennewick. This is the Kennewick experience of underground injection control and looking at some of this regulatory framework that Doug just provided. I'm going to give you a quick look at, here's City of Kennewick is in the southern portion of the central region. We do have some higher temperatures and some lower temperatures in some other parts of the state farther west. If you look in the manual for Eastern Washington,
Nice.
you can see we're sitting down here in Benton County. If we zoom in a little bit, you'll see City of Kennewick is in one of the driest regions in the state. We end up with 6 to 8 inches of rain a year and about 1.6 inches in 25-year storm and 1.8 in 24-hour, 100-year 24-hour storm. So Kennewick was incorporated in 1904, and since that time we spent a majority of that time with this concept of localized infiltration. There are pipe systems that do go to the river, but there is a large portion of the city that has long been dry well infiltration trenches, things like that. So, and that's good news. We've also got a large portion of these dry wells that have always been, they were installed originally as kind of a two-stage dry well setup with catch basins ahead of them with sumps. And for a long time, we have asked that private residents retain stormwater on site. Is it some forethought that the folks of the City of Kennewick had years ago? I don't know. It was probably more likely the cost. Some of the city grew early enough that putting water into the ground just made sense instead of making lots of expensive pipe connections to other places. It's all viable because of this low rainfall. And today, most residential commercial subdivisions use dry ponds for surface infiltration. And most of the commercial sites use UICs. It's all kind of LID stuff, not really new to Kennewick, but we have tried to modify our standards and add additional detail as we've gone along to tighten up treatment and help people use the material that's now a part of the manuals. Two of our larger basins that don't use runoff, or excuse me, infiltration on site, run their water, they tight line it into a series of ponds before they go out to the Columbia River. And this is one of those sites, a basin in the city where if you're looking at the bottom right corner there at the bottom south end of that golf course, there's a series of orange pipes that enter there. And they go through a series of ponds where they have some opportunity to settle out, and they end up heading then across underneath the state highway we've got an opportunity to select where the water goes from there. Typically, it goes to another pond and then is able to go out to the Columbia River. So that's how we deal with those tight line systems. And some of the tight line systems are simply overflows from areas that do have dry wells or infiltration trenches. So it's a combination of flood management and in some cases it's a portion of the treatment element. And as a side note, the Columbia River, at least at this river mile, doesn't have any flow control, but more specifically, we don't have any TMDLs that we're reacting to in the City of Kennewick. So, soils. If you've been dealing with stormwater, you know that soils can provide great treatment. So one of the things that we did with Aspect Consulting this last year, a year before, we put, because it was more than a year ago, 2020 went by in a flash, we went through and did an update to our comprehensive plan. And one of the things that I always like looking at is the soils map. But it really doesn't do you any good unless you really know the soils well. So one of the other items we've got in here is a hydrologic soils group map. You can see the different soils groups. The most prevalent one in the center of the city is Group B. Group A, mostly along the northern edge of the city. And there is some Group C in there. I'm showing you all these things because these are planning tools for an engineer and a developer to figure out what kind of site they're going to get involved with. But there's some more detail that you need to go through. I'll keep going through a few more of these though. So it's also important to know, do you have any wells? The City of Kennewick has 2 large well protection areas. We've got our rainy wells on the north end of the city where the majority of our water is pulled from. So this large set of dotted lines to the northeastern part of the center of the map there, that's a 10-year time of travel where if something entered the ground, we predict that in about 10 years, we might see that water get to our wells. So obviously there's supposed to be a bunch of treatment that happens there, but that is an area where we have some specific development criteria that's placed upon development community when they're putting a project together. The southwest corner, we do have an ASR. It's a well that it's a 1,000-foot deep well that we store water in. So we pump and treat water and stick it in a big hole in the ground. And then we suck it back out to modulate flows. But you have to plan your project accordingly. Another piece of information that we didn't include in this cycle's comp plan, we did it for a reason, but it's really interesting information. And this is a depth to groundwater map of the city. And this looks like topographic lines, but really, if you look at it, you'll find there are areas on this topographic map in the center and south end of town where you may have more than 100 feet to seasonal high groundwater. That's a long way to go. There's also portions of the city where it's less than 5 feet. So again, from a planning standpoint, you could look at this and help get an idea of what you're getting into. Let's take this a step further though. Let's talk about an actual project because when you look at all that stuff and you start planning, at some point you have to deal with the reality of the information that you have. And NRCS soils map information is great stuff. And the more time you spend reading it, the more informative it can be, but there is a limit. It is not super deep. Some depths 6 feet, 8 feet. Other places the depths are different, but there is an unknown material hiding under there. It could be clay, caliche, something like that, or it could be bedrock, or it could be frayed drainage soils or gravels. If you don't know, you just don't know. So I just wanted to show, this is an example that I try and share with the engineers that we deal with that think they have what they need when they start designing a project. So let's say that, we're looking at a site and we decide, all right, we're going to look at surface infiltration. And we decide, okay, well, we probably have a good vadose zone there. We think we know what that material is. We're probably okay, right? So should we move on with our design? Well, maybe not. It's what you feel comfortable with, and then at the city what I feel comfortable with. If you provide enough information, maybe we'll move forward. But if you haven't provided enough data, we'll probably need some more geotech work from you. But once you start moving into infiltration trenches and you start looking at vadose zones there, and you start looking at dry wells and you look at the vadose zone there, it doesn't take very long to realize that you really don't know what's going on under there, and you're probably not making good engineering decisions about the project. Let's take this another step further, and let's talk about the difference between that same kind of concept on flat ground versus hillside. And on flat ground, let's say that you do your due diligence and you dig a test pit and you know exactly what's down there, and you decide, yes, I do know that I'm clear of any obstructions, I'm clear of any groundwater. That's great. Well, let's look at that same kind of scenario on a hillside. So let's say you've got some sloping ground, you do some tests, you think, all right, I know what's down there. You know, the geotech does his job. Engineer comes along and says, all right, I'm going to build a subdivision. I'm going to need some streets. I'm going to need some pad sites for homes. So this is the new cross section of the site. And if you notice, you don't know the same amount of information. You don't really know what's under those tests. So when you start putting dry wells in, and you start trying to consider where the water is going, you may think you understand it still until you start looking at the reality of the rest of the site. Maybe some home pad sites are going to be fine, but maybe others won't. And you may end up with water that is removing the ability for this house to stand on its own 2 feet. So you could have settlement and basement, settlement or basement flooding. Let's say you have another infiltration structure, dry well, down the hill a little ways. Well, if it's receiving water from the previous few storms running through the underground subsurface material, it may not work very well at the next storm. And it can get even worse when you start adding trenches. In a roadway, you have water, sewer, irrigation, other storm lines that are tight lined through there. And when the water comes in contact with those trenches, it'll start settling them out and start running all over the place. And we've seen that. And unfortunately, we've seen it to the cost of the city and to the cost of contractors and owners. So, you know, in addition to looking at the requirements in the Stormwater Management Manual, looking at cationic exchange, or looking at other site suitability criteria for certain structures, in addition to looking at what is down there, you know, one of the City of Kennewick's requirements is to provide an infiltration trench at the location and depth of the infiltration structure and a soils log 5 feet below that. Well, that's not always enough. And in the hillsides and in these unknown areas, you really do have to do more. So those are, I guess that's the Kennewick experience. We follow the manual, but we have looked and we've added a little bit more in addition to that. So one of the other things I said I would talk about is maintenance in the COVID environment. And so I'm going to take a couple minutes to talk about that, and then I'll finish up. So COVID, it was a problem for everybody. It slowed down our ability to do lots of things: water, sewer, streets, all the maintenance. Inspections was a problem. The solution...
Martin, I hate to interrupt, but we have 1 minute left before we get cut off.
Okay, all right, so I'll make this really short. So, short solution: let your crew go do their job and contract out as much as you can. We contracted out crack sealing, and we reorganized the crew, and we let our guys inspect. And that allowed us to get back on track and catch up. So we're good for 2020. That's all I got.
Fantastic. So unfortunately, it looks like I just received notification. We can go a little bit longer if needed, but I'm not seeing any questions in the chat at this point. So if you have questions, please quickly type them in so we can get Doug or Martin to answer them. still none, but that's okay because for those that still have questions, they can contact the presenters directly and their information can be found in the conference program. And again, I guess I'm gonna say that marks the end of our session. Thank you, Doug and Martin, for presenting this topic at Municon 2021. All of you have a great day. Thanks for attending.
Thanks, Doug. Thanks, Amanda.
Thank you. Thanks, Martin. Thanks, Amanda. Amy.
Thanks, Amy.